Jai Hind students, myself Abhishek Tiwari. Again, we are here for the 7th lecture of satellite communication. Today, we are going to start our third unit, and this third unit is basically divided into two parts. First one is satellite subsystem and second one is satellite link design. So, starting from the satellite subsystem. Subsystem, basically when we want to talk about a system, means a specific combination of various devices, circuits or blocks to perform a specific task is called system, and the various block of that system are called subsystem. Similarly, in satellite subsystem, we have actually two segments. The first segment is the earth station, which is situated on the earth, and the second one is the satellite itself, which is situated in the space. And between both of them, there is a link that is called communication link, in which one is uplink and the second one is downlink. These both links are used to transmit the signal towards the satellite, and also it for the receiving purpose you use that downlink channel. So, when we are talking about the satellite subsystem, means we have to identify and explain all the blocks, all the subsystem related to the satellite communication, and that is starting from the earth station and space segment. As we already discussed this earth segment in the previous lectures, now we are concentrating on the space segment, means on the satellite part. This is the picture of a satellite, and if you can identify this, a basic satellite has various components, various block, various devices such as these solar panels, these antennas, the propellant tank, the battery packs, the compartment for the single access, then the payload module, thrusters, liquid apogee motor. These all blocks, or we can say that all devices combinedly make a satellite. And whenever you want to explain any satellite working, you have to identify the functioning of these various blocks. Basically, we are showing here NASA TRDS satellite for your reference. If anyone want to know that this picture of which satellite of this picture, that is basically NASA TRDS. So now, when we are talking about these subsystem, we broadly classify these subsystem into 5 subsystems. These subsystems are, first one is attitude and orbit control system, then TTCM, telemetry, tracking and command subsystem, command and monitoring subsystem, then the power subsystem, then antennas that are used by the individual satellite, and the communication subsystem, which is responsible for the all communication which is governed by the earth station and satellite. So, these all subsystem combinedly make a satellite. Now, starting from the AOCS, as its name suggests, attitude and orbit control system. Whenever your satellite is placed in the orbit, various forces will act on the satellite. That forces are due to the sun or moon gravitational forces. And also I want to mention, sun gravitation force is 3 times more stronger than the moon. So, when we are talking about these gravitational forces, here I am showing a geo-satellite orbit, in which you can see our Earth is not complete sphere. Actually, there is a buzz of 65 meter on the equator, and due to that buzz and due to the sun and moon gravitational force, these satellite always face various forces which push satellite to you can say that just satellite अपनी attitude and orbit को छोड़ दे. It means these forces are responsible for the orbital disallocation of the satellite. So these stable points are basically defining the satellite position or the stable position of the satellite, and these drifts are basically related to the sun and moon gravitational forces which are acting on the satellite, and this complete structure will show how a satellite is facing the forces in the orbit. Then this is about the attitude and orbit control system working. When we are talking about the attitude and orbit control system working, means you have to maintain the attitude and orbit of a satellite in its position. When we are talking about these 2 points, attitude means height or height of the satellite, and orbit means orbital position of the satellite in the orbit, you use 2 types of technique. That techniques are spin stabilization, and second one is 3-axis stabilization. As if I will give you a example, in your childhood, when you are playing some games, you can easily see that when you are playing on a merry-go-round, and if you are standing in the center of the merry-go-round, at that time you can see that if you expand your hand in this position, your speed will decrease, and if you compress your hand in towards in this position, then your speed will decreases. So that same condition is used for the spin stabilization. Means in this type of attitude and orbital control system, specific thrusters and jets are used to provide specific spin to the satellite, so that satellite can be stable in its attitude and orbit control system, in attitude and orbital position. But in the spin stabilization, there is a problem. This is applicable only for LEO and MEO satellites, because large satellite cannot be maintained in its attitude and orbit by this spin stabilization, because there is a requirement of much power to operate these thrusters and jets. Means if this fan is your rotating satellite, means a cylindrical drum is there and this is rotating in this direction, and this rotation will provide this spin will provide the specific velocity and to the satellite, so that it can maintain its attitude and orbit. So in the spin stabilization, this is applicable only for the LEO and MEO. But when we are talking about the large satellite such as geo satellites, we use 3-axis stabilization. In 3-axis stabilization, actually we are having coordinate system. We are taking here 2 coordinate system. First one is Cartesian coordinate system, that is denoted by ZR, YR and XR. These 3 coordinates are related to the Earth distance and for the satellite. So these are with respect to the earth or the center of the earth, means these also called as yaw, pitch and roll, means you are using three different position to maintain the attitude and orbit of the satellite. How it is going to work? Actually, for each part, for each coordinate, whether it is yaw, pitch or roll, you are going to place a set of two thrusters or jets in opposite direction. That both jets are giving the thrust to the satellite. So if your satellite is dislocating from its orbit or attitude, in that case that thrusters will be on by the command given by the telemetry tracking and command system, and that thrusters will maintain its attitude and orbit position. So it means if this is your yaw condition and you are placing two thrusters, one in this side and one in this side. If your satellite is dislocating in this direction, means this side thruster will be on and this will provide, and this will again maintain this satellite in this orbit. If another direction it is going, then the opposite side thruster will be on and it maintain again the satellite orbit. So similarly, we have three different set of thrusters for yaw, pitch and roll. So in 3-axis stabilization, what will happen? You can see that you only on the thrusters on jet or jets in the specific conditions when the TTCM system is sending you command to on the jets or thrusters. But in the spin stabilization, you have to provide continuously spinning to the outer structure of the satellite to maintain its orbit. That's why continued power is required to thrusters and jets, which consume very much power. That's why for the large satellite, 3-axis stabilization is used. Now, this is the 3-axis stabilized geosatellite AOCS system. In this, you can see that we have 4 sensors that are basically gyroscopic sensors, and that gyroscopic sensors are placed in this type of arrangement through the earth sensors. These sensors are sun sensors, star sensors, earth sensors and gyro sensors. These all sensors are giving the information about this drift points, and then these conditions are applied to the attitude controller. That attitude controller is identifying the satellite position, that whether satellite is on its place or not. Then the command is going, that the signal is going towards the TTCM system through the earth, and then earth station is going to process that data and generating the command, and that command will be given to the attitude controller through the telemetry tracking and command system, and then that command will activate the momentum wheel or thrusters to maintain the satellite position. So this is the working of the 3-axis stabilized geosatellite. Similarly, if you are talking about the simplified diagram of the same AOCS system, the same that point is there, that sun sensor, star sensor and GPS receiver are there. They all are giving the data to the orbital controller, and orbital controller are communicating with the TTCM system of the satellite through the earth station, so that command is coming from the earth station and the thrusters and other flywheels or other things can be operated as per the requirement. So you can see that where we have some solar panel controllers also, so that you can maintain the position of the solar panel also as per the requirement. So there is also a feedback provided for the solar panel arrangement can be maintained. So this is about the attitude and orbital control system. Then coming towards the next, that is telemetry, tracking and command and monitoring subsystem of the satellite. Basically, in the previous diagram, you can see that this telemetry, tracking and command system play a role to operate the AOCS, means all these subsystems are combinedly working for the satellite. So now we are talking about the telemetry, tracking, command and monitoring. Now take one by one all the words. First one is telemetry. What is the meaning of telemetry? Telemetry means whenever you are accessing any data from the remote location to any other distant location, then you are requiring that telemetry. And tracking is basically about the location tracking of the individual object, so that you can identify where the individual object is at the time when you are observing. Similarly, third point is command. Command is basically about the giving instructions. As AOCS is giving the signal to the earth station that satellite is losing its attitude or orbit condition, orbit location, then the command is going to be generated by this TTCM system at the earth station and giving that command to the earth to the satellite to on its thrusters or flywheels. Similarly, the monitoring. The monitoring is basically related to the satellite health monitoring. Actually, satellite is working in very harsh conditions. When satellite is in the front of the sun, means between the earth and the sun, then its temperature will be very high. But in the blind region, when the satellite is in the shadow of the earth, at that time its temperature is quite low. Means its temperature is continuously increasing or decreasing. Similarly, there are various other parameters also, such as the power supply, such as flow, pressure. All these things have to be monitored all the time. To monitor that parameters, we required this TTCM system. So combinedly, this system will make a telemetry, tracking and command and monitoring subsystem. You can see that here we have three individual sections. First one is telemetry section, second one is tracking system, third one is command. Monitoring is somehow related to the telemetry receiver, that's why it is combined in this part. How it is going to be work? You can see this is the satellite, or we are taking example of geo satellite. This geo satellite have two things, two types of antennas. One is S band and second one is UHF antenna. Both antennas are used for the TTCM system. You can see here the data from the satellite given to the TTCM system through S band and by using this parabolic reflector antenna. That data is coming to the telemetry receiver. Then telemetry receiver will decide that this data is related to the attitude and orbital control subsystem or the satellite health monitoring. Then as per the requirement, that data go to the telemetry computer and telemetry computer give that data to main computer, where main computer will process the complete data and create the commands. That command will be given to command computer and that command computer will give that command to command transmitter, and that again that data will be transmitted through the same antenna to the satellite. Also UHF transmitter or receiver is also used, same for the telemetry receiver part. Then we are talking about the tracking. Tracking is somehow related to the telemetry because for the tracking you need the satellite location or the coordinates, and that coordinates are also coming from the AOCS attitude and orbital control subsystem, and the same data is divided from here tracking system and then applied to the main computer. It means TTCM for the geo satellite combinedly working all these four processes at the same time. This diagram is specifically in the sense of the S band and the UHF band for the geo satellite, but you can also use this diagram for the simplified version. This is just simplified version. Here we are showing two antennas, receiving antenna and transmitting antenna, but you can also understand one thing. Single antenna in duplex mode is also used for this TTCM part. So it is not always required that there are two antennas for the TTCM system. Sometimes, as shown in this previous one, you are using the same antenna for the transmitting as well as receiving the data. So antenna is going to be used in the individual duplex mode. Then same again, the data is coming, and you can see that the data going towards the telemetry, if that is a telemetry or monitoring data, or if it is a tracking data, then it will coming to the tracking system. Again, telemetry data will be processed by the data processor or the telemetry computer. Then all that data or tracking data or telemetry data is going towards the computer for attitude and orbit control. That computer for attitude and orbit control will generate the command as per the requirement. That command is going towards the controller and the telecommand transmitter, and that is sending the commands to the satellite. As per that command, satellites, thrusters or jet will be on and off, and the satellite will maintain its position in the orbit. Similarly, for monitoring, we have some ephemeris data, that is monitoring the health of the satellite, such as the flow, pressure, temperature, other things. So that is the ephemeris data, and that is recorded in the earth station recorders or the basic requirement. So these are the first two subsystems of the satellites, in which we have AOCS, and the second one is this TTCM. AOCS is for the attitude and orbit control system. TTCM is for the telemetry, tracking, command and monitoring subsystem. In the next lecture, we will talk about the next subsystem, which are power systems, antennas used by the satellite and the communication subsystems. So thank you for till the next lecture. Thanks.